In the last couple of videos we've been looking at the binomial expansion. We've expanded binomials to positive integer powers and used either Pascal's triangle or the NCR method to find the coefficients. In this video we're just going to work through a range of different questions involving the binomial expansion. So let's start off. In question 5, part A, it says expand fully 1 plus 2x to the fifth in ascending powers of x. So this will be x to the 0, x to the first, x squared, x cubed, right the way up to x to the fifth. I can now choose how I want to find my coefficients. I can either use Pascal's triangle or the NCR method. I'm going to use Pascal's triangle. We will have 1, 5, 10, 10, 5 and 1. You can of course do 5C0, 5C1, 5C2, 5C3, 5C4 and 5C5. So let's go ahead and write this out. I'm going to write it out fully. We could use here the 1 plus x to the n method. In later videos we will look at that particular approach, but using this way is equally valid. So if I do that, we're going to have 1, we will have 1 to the fifth, and then we'll have 2x to the 0. If this doesn't mean anything to you, please check out those videos as we've done some examples like this before. Then we'll have 5, we'll have 1 to the power 4, we will have 2x to the power of 1. We can see these are the binomial coefficients using Pascal's triangle. These two add up to 5 and we just continue to write them out. 10, then we'll have 1 to the power of 3, we will have 2x which we need to square. Plus 10, we will have 1 now to the power of 4 on here, sorry, 2. And then on here we will have 2x to the power 3. Then we'll have 5, we'll have 1 to the power of 1. Then we will have the 2x to the power of 4. And then finally we'll have 1, we'll have 1 to the 0. And we'll have 2x which we need to raise to the fifth power. So just writing this out, this is 1 times 1 times 1, which is 1. Plus now 5 times by 1 times by 2x. So that's going to be plus 10x. I've got 10 times by 1 by 2x which we need to square. 2x squared is 4x squared. Sometimes students make the mistake of just writing this as 2x squared. It isn't, it's going to be 4x squared, so that's plus 40x squared. 2 cubed is 8, 10 times by 8 is 80, so this is going to be plus 80x cubed. This one is 5 times by 2 to the fourth. 2 to the fourth is 16. 5 times 16 is also 80. That's 80x to the fourth. And then finally 1 times 1 times 2 to the fifth. 2 to the fifth is 32. So we get 32x to the fifth. So nice and straightforward. We've gone ahead and fully expanded 1 plus 2x to the fifth. In part B it says hence write down the full expansion of 1 minus 2x to the fifth. This is telling me not to go through this process again, but it's simply now asking me to consider what's going to happen if we have the negative here. When we have a negative and an odd power, so in this case 1, 3 and 5, the answer is going to be negative. If I substituted negative 2x into the first power, that's going to be negative 2. If I put it in here, it will be negative 8. In here it will be negative 32. But in all the other powers, the 0, the 2 and the 4, we're going to end up now with, here we'll have just the 1. Here, when we square it, we'll get positive. And when we take it to the fourth power, we'll also get positive. Therefore, I can simply write that this will be 1 minus 10x, as this is the first power. That will be a positive, as it's the second power. This is going to be negative, as it's the third power. This is going to be positive as it's the fourth power, and this is going to be negative as it's the fifth power. So all we've done is simply written it out, considering what happens when we have a negative and an odd power, as we saw in the last video. In part C, we need to simplify 1 plus 2x to the fifth plus 1 minus 2x to the fifth. So let's write this out. I'm again simply going to use my answers from before and add these up. So what we'll have now is the following. 1 plus 1 is going to give me 2. 10x minus 10x is 0. Then we're going to get 40x squared plus 40x squared, which is 80x squared. These will cancel and give us 0. That will now add to give 160x to the fourth. and these two will cancel, and that is our final answer. So all we've done is simply use the expansion and then used a bit of logic to simplify this final answer. Okay, question 6. In part A, we're asked to find the term in x to the fifth in the expansion of 5 minus x all to the power of 12. So we're looking for the coefficient, that is the number in front of x to the fifth. The advantage of the NCR method is that we can jump straight to that term. So what we can write out is 12c5. We will have now 5 to the power of 7, and we will have now negative x to the power of 5. This is going to give me a negative answer, as we've got a negative and an odd power. So all I need to do is the following. I need to find out 12c5. I need to times that by 5 to the power of 7, and then times it by negative 1. We're simply finding the term, the coefficient. So let's go ahead and put that through a calculator. So in a calculator, we can write that this is 12c5, so 12c5, and that would give me 792, multiplied now by 5 to the power of 7, and that's going to give me now 61875 000. So 61875 000, and that is a negative. If this had been now to the power of 6, then it would have been a positive, because we would have had an odd with now an even power with a negative, which would make it positive. Okay, let's look at the next one. We need the term in x to the 7th of the expansion. Now in the expansion, 1 plus x over 3 to the 9th. So again, 9c, and we need 7. Then we're going to have now on here, 9c7, we will have 1 to the power of 2. Then we will have x over 3 to the power of 7. So what I'm going to do here is simply do 9c7 times by this value, which is just 1, which of course we don't need to do, and then we're going to have 1/3 to the power of 7. Positive value, as we've got a positive just here, and we can go ahead and do that. So 9c7, in fact I'll do it in one go, so we can do 9, then c7, so 9c7, and then we're going to multiply that now by 1/3 to the power of 7. Let's put that in, and that's 4/243. So 4/243, and that is the coefficient, or if you like, the term in x to the 7th. I can, of course, write x to the 7th here. So that's what we end up with. You can, of course, if you wanted to work out 9c7, remember 9c7 is 9 factorial over 7 factorial 2 factorial. So this is actually 9 times 8 divided by 2. The reason being is because it's 9 times 8 times 7 factorial, and of course the 7 factorials will cancel. We discussed this in a previous video, so that is simply going to give us 36. But again, you don't have to, as it's a calculator question. In question C, it says find the term in x to the 18th in the expansion of 0.5 plus x cubed to the power of 13. If we consider this is going in powers of 3, so the first one will be x to the 0, then we'll have x cubed, then we'll have x to the 6, ... and so on. Using the rules of indices, a to the power of m raised to the power of n is equal to a to the power of m multiplied by n. So what I need here is the 7th term, or we can write that this is 13c6. That means that I'm going to have 0.5 or 1/2 to the power of 7. Then I'm going to have my x cubed to the power of 6. You can now see that this term is going to give me x to the 18th. So all we need to do at this stage right here is simply do 13c6, which I'll do on a calculator, multiplied now by the value of 1/2 to the 7th. 1/2 to the power of 7 is going to be 1/2 to the 7th, which is 1/128. You don't have to work that out, you can just put it into a calculator. So 13, and then we'll have now 13c7. Let's 13. Have we got 13c6? 13c6 Doesn't matter if it's 13C7, it'll give us the same answer, which I'll just show, because they're symmetric. Okay, let's put that on. So there we go, and all we need to do is divide that by 128. So divided by 128, and that's going to give us now 429 over 32. So 429 over 32, and that is the term in x to the 18th. So that's what we get. The coefficient is 429 over 32. And if you remember, we discussed this before, these are symmetric. So 13, and I'll write it like so, 13, and we can write the 13C0 as we saw, that's going to be the same as 13C13. Then you'd have 1 and 12 in the bottom, you'd have 2 and 11, these are symmetric. 3 and 10, you'd have 4 and 9, let's keep going with this, 5 and 8, 6 and 7. So we can see that these ones are symmetric. And again, from Pascal's triangle, hopefully you should see that that's true from there. So there we go, nice and logical, nice and straightforward. In question 7, we're asked to find the term in x cubed in the expansion of the bracket 3 plus 2x multiplied by the bracket 1 minus x to the 6th. Depending on your confidence, you could just go straight ahead and do this. And I'll show you how we could do this. As we saw in a previous video, this is the one we expand using the binomial expansion and then multiply through. This is the constant and this is the term in x. So if I have now the term in x squared, whatever it is, and the term in x cubed, then I can just jump to them. It'll be that one multiplied by that one, and this one multiplied by that one to give us now the terms in x cubed, which we can simplify. If you're not confident with doing that, perfectly fine, you don't have to. What we can do is simply go ahead and write this out. So what we could do is 3 plus 2x, that's the single power bracket. Then we'll have 6c0, we'll have 1 to the 6, and then we'll have negative x to the 0. Plus 6c1, we'll have 1 to the power 5, we'll have now negative x to the power 1, plus, and this is what's where we're interested in, these terms right here, that's going to be negative x, and we need to square it, plus 6c3, we'll have 1 cubed, and then we'll have negative x, which we need to cube. So you can see what we're going to be doing here is taking the constant, that's the term without an x or independent of x, multiplying it by this term right here. That will give me a term in x cubed. And then what we're going to do is multiply the 2x, and it's a positive, let's get that. And we're going to multiply it with this one right here. Again, all we'll end up with on this particular one is a positive. So let's go ahead and do that. So what I'm going to do is the following. If I look at it now, I've got 3, and then I'm going to multiply it by this here. So what we're going to have is the following. I'll just write this out. We'll have 3 times 6c3 times by 1. That's just going to be 1. Now this is going to be negative. So I'm going to times this by negative 1. Then what we're going to do is add to it now the 2. That's the 2. I'm going to multiply this by 6c2, multiply it by 1, and then of course this is just going to be positive. So let's go ahead and do that. Now if you wanted, you could you could of course just work these out yourselves. If not, it's perfectly fine. So 3 times by, and then we can do, you can use Pascal's triangle or the method that we've seen before. Let's put this in. So 6c3. What's this going to give us? 60. Let's just do that. 6c3. So that's going to give us negative 60. That's fine. So that's negative 60. Then we're going to get on this one, 6c2 is 15. Remember, we can find 6c2. 6c2 is 6 factorial over 4 factorial times by 2 factorial. So if you wanted, you could write this now on here as 6 times 5 times 4 factorial over 4 factorial times by 2 factorial. The 4 factorials will cancel, and you can see that's 15. So 2 times 15 is 30. So from here we can say now that the term in x cubed is going to be negative 30x cubed. Again, you can use a calculator to find this out. It's perfectly fine. So the coefficient is going to be negative 30. If you wanted, you could simply now jump straight to this. So you would have had 6c3, 1 to the third, negative x to the third, multiplied by 3, and then jump to the second term. If we were asked to expand this out fully, or the first 4 terms, then we would have to go with this method and do that. Of course, as well, later on in the video series, we will look at the 1 plus x to the n method, which we could have used on this in here as well. Or you could have got your Pascal's triangle to find the coefficients. Okay, in question 8, we're asked to find the term independent of y in the expansion of a, y plus 1 over y to the 6, and b, 2y minus 1 over y squared to the 12. Okay, a few different ways of looking at this. One way is to consider the powers increasing and decreasing. They will decrease on this term from 6 to 0 and increase on this term from 0 to 6. If we just think about it now, if we get to the point of where we have y to some power multiplied by y, 1 over y to some power, this is going to be 1. So it's going to be independent of y. If I look at this, and one way you might want to think about it if it isn't intuitive, if we look at the powers of y, we will have the power of 6 to begin with, then 5, then 4, then 3, then 2, then 1, then 0. If we look at this one, what we'll have now is starting with 0, then we're going to have 1, then we're going to have 2, then we're going to have 3, 4, 5, and 6. If we look here, we can match these up. So I can write that this will be 6c3, and then we will have now y to the third, and then we're going to have now 1 over y to the third. That is going to give me the term independent of y. So all we have to do is work out what 6c3 is. Can either do that in a calculator, or we can do it from Pascal's triangle, or you can work out in your head. So 6c3, so let's go ahead and do that. What are we going to get on this? 20, 6c3, that's going to be 20. So what we've got then is 20, and then of course this is just going to give us 1. So that now is the term independent of y. The value is 20. We don't have to fully expand it out, we just jump to it. Okay, now let's look at the next one. What we're going to get here is the following. We've got 2y minus 1 over y squared. These will be descending, so we'll have now 12, we will have 11, we will have 10, 9, 8, then we're going to have 7, 6, and so on and so forth. Here we're going to have 0, 2, 4, let's put in 4, 6, and 8. We can see now that this is the combination we want, and we can jump straight to this. So I'm going to write out that this will be 12c4. Reason being, if we want the 8th power, as we saw in the last one, we need now the 5th term or the 4th power. We need to be careful here, and what we'll have is now the 2y, which we need to take to the power of 8. Then we're going to have now minus 1 over y squared to the power of 4. Okay, if we look at 2 to the 8th, so let's write this out, 12c4, then we're going to multiply this by 2 to the 8th. Now 2 to the 8th is going to give me 256, so 256. Then what we're going to have here now is simply, and I'll just put this here, y to the 8th, and then we're going to have this one, which is going to be now 1 over y to the 8th. The reason it's going to be positive is we have a negative and an even power. So all we've got to do here, we can see quite clearly these are going to cancel off. So that will cancel with that. Y to the 8th times 1 over y to the 8th is just 1. So all we need to do is do 12c4, so 12c4, and that's going to give us 495 times by the 256, and that gives us 126,720. So 126,720, and that is a positive number. So we've just considered the terms. There are alternative methods on that one. I think that's a nice way of doing it though. So there we go, 4 questions using the binomial expansion, all we're doing is simply going ahead and taking what we know and applying that to slightly more challenging questions.